Okay, microeconomics students, ECON 2302, good morning. Professor Lewis again. We have two more videos. This is the second to last one for Unit 1. And this one is dealing with some more properties of price elasticity of demand, which symbolically is a capital E with a subscript of D. We're going to talk about how does this relate to a concept called total revenue. Total revenue represents money income earned by a business and also leads to pricing strategies. Businesses that face price elastic demand, if they know for sure that's the case, will have a different pricing strategy from those that face price inelastic demand. Now, some students say, well, I thought businesses were on the supply side. True, but who are the businesses selling to? Their customers. And customers are on the demand side. And so you have to know who your customer is. And so part of that means you need to know, do you face price elastic demand or do you face price inelastic demand? Because it gives you a notion of how much wiggle room you have as far as pricing. So we're going to go back to the PowerPoints first of all. So I'm going to share the screen here. And then we'll get our tunnel effect as I go to PowerPoint. Let's hide this for a moment. Okay. And let's go to the slideshow. I want to go back to the beginning here, just kind of rehash a couple of things first. So again, please bear with me for a moment. Okay. Now, price elasticity of demand, we're going to focus on the general formula today. E sub D, or price elasticity of demand, is equal to the percentage change quantity demanded divided by percentage change in price. Please remember, unlike what the textbook may say, we do not drop the negative sign because of the law of demand. We're going to be using the general formula now because we're trying to figure out, should businesses raise or lower their prices by a certain percent to boost their revenue? Now, of course, to understand what we're dealing with here, we need to first talk about what's total revenue. Total revenue is the money income a firm earns from selling a certain number of units of a good at a specific price in dollars and cents. And the formula says total revenue, or TR for short, you got to get to know some alphabet soup in this class, is equal to price per unit of output charged times quantity of units sold. Not produced, sold. What's interesting to note here, though, is that when you talk about price elasticity of demand, we learned about demand being price elastic, price inelastic, and we're not going to worry about unit price elastic because that doesn't happen except for one single point. What we learned already earlier was that if demand is price elastic, the E sub D coefficient would be something like -7/4 or -4. It would be between negative infinity and -1. And what that tells us is the quantity demanded changes by a larger percentage than the price changes for that piece of the demand curve. And so in that particular segment, quantity demanded is very sensitive to changes in price because quantity demanded will change by a bigger percentage than price will. Now, if demand is price inelastic, that would be a number like -2/3, -1/2, -3/4. It has to be between -1 and 0. And so that would tell you that quantity demanded is not sensitive to changes in price because price is going to change by the bigger magnitude than quantity does. And remember, we're talking about demand. Law of demand says if price goes up, quantity demanded goes down and vice versa, and that's including percentages. So the thing here is, what we have learned up to this point is about what E sub D is, but here's something interesting about total revenue. If a business is currently selling a certain number of units of a product at a certain price, and they want to know, how do I earn more revenue? How do I get more money coming in to offset my costs? If the business knows for sure that their demand is price elastic, the firm's total revenue will increase, but if they lower price. Now, I don't mean lower price a ridiculous amount. You charge $0.00 for something, you aren't earning any revenue. That's silly. But it means you could lower price by a small amount and you would end up selling a much bigger amount of quantity. And this is in percentages, not in units I'm talking about here. The flip side is if the demand is price inelastic, the firm will actually boost their revenue if they were to raise price because price changes by the bigger percentage than quantity. But remember, they change in the opposite direction. And E sub D of -3/11 would tell you this business could increase price 11%, and they would end up only losing about 3% of their sales. And since 11 is bigger than 3, it kind of wipes that out. And actually the price increase is going to dominate and give larger total revenue. But if you had an E sub D of say -7, you would have to lower price 1%, and you could actually sell 7% more. And since the 7% increase in quantity is bigger than the 1% drop in price, it overpowers it and again leads to more total revenue. I've mentioned price unit elastic, E sub d equal to -1. That happens at a single point. We're not going to worry about that. We're going to be dealing with just these first two because that's what typically happens. Now, in order to be able to talk about what will the new price and quantities be, you have to know how to apply a percentage change to numbers. And very conveniently, I've included that in your slideshow. If you are dealing with a problem and you state that, well, we need to lower price 1%, well, how do you do that? Or if you'd stated in a problem, you need to, our quantity is going to rise 7%, how would you do that? Well, here's how you would do that. The new value after the percentage adjustment is going to equal the old value times 1 plus the percentage change as a decimal. And please notice the parentheses. You have to do 1 plus the percentage change as a decimal first before multiplying by the old value. Example, if you're saying quantity sold increases 7%, 7% as a decimal is equal to 7 divided by 100. Percent from the Latin, divide by 100. 7 divided by 100 is 0.07. So the new value would equal the old value times 1 plus 0.07. Or to keep it simple, it's 1.07 times the old value. That's how you do an increase of a percentage. Now, for a decrease of a percentage, you have to take the old value and multiply by, again, parentheses, got to do this part first, 1 minus the percentage change as a decimal. If you're saying you're cutting price 1%, 1% as a decimal is 0.01. So 1 minus 0.01 is equal to 0.99. So the new value will equal the old value times 0.99, okay? And this is a very simple way to do this here. Now, some people would say, well, why don't we just figure out 1% or 7% first and subtract from the old value? And my response is you can do that, but you're adding extra steps. And we want to try to do this as simply and directly as possible and hopefully minimize errors. So I'm going to go over here, and this is problem number 5 on the practice problem set. We've been given some information here, and I want you to notice the starting price and starting quantity are already given. So P0 is equal to $10.00, and Q0 is equal to 100 units. And so the initial total revenue is going to be $10 times 100 units. And class, listen up. Total revenue, total cost, prices, wages are all measured in dollars and cents. $10 per unit times 100 units is equal to $1,000.00. And so let's go over here to the worksheet that we're going to do for this here. And so we're going to make a little note, TR sub 0 is equal to, and I will make that a subscript for us. And please just be patient with me while I deal with this Microsoft Surface. Sometimes it's a little bit tricky here. TR0 is equal to $10.00. Please remember, you will be handwriting this. Do not type the handwritten homework. That's equal to $1,000.00. So in part A or part B, we have to make sure we recommend changing prices in such a way that we're going to have a larger total revenue than we did before, more than $1,000. Now, let's start with part A. Part A says that E sub D is equal to -5 ninths. -5 ninths. Now, is that between negative infinity and -1? Or is that between -1 and 0? Think for a moment. Do, 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 do. Okay. Seriously, I always felt the Jeopardy theme should have like a tooting sound at the end, but whatever. Folks, 5 negative divided by 9. Negative 0.5555555 going on forever. That is between -1 and 0, which means demand is price inelastic. Okay, so let's go back to what we learned about with total revenue. It says if demand is price inelastic, the firm's total revenue will increase when they raise the price. So let's go back to our problem over here. Now, the second thing we have to do is figure out what percentage that we have to change the price by. And oh, here's a little reminder, our point elasticity formula for E sub D. Negative is because one goes up, the other goes down. We're raising price because demand is price inelastic by, what's the denominator? 9. So we're going to raise the price by 9%. And if price goes up 9%, the quantity demanded, the quantity sold, will drop by what percentage? What's in the numerator? 5%. So let's go ahead. We're going to work this over here, and let me just zoom out so it's a little more visible. Y'all may want to use a large computer or pipe this over to your TV for casting, if you will. So since demand is price, inelastic, we recommend increasing price by 9%. Okay. Hey, I'm going to make a couple of minor adjustments here. Okay. So new P is equal to, remember our formula here, let's go back to that slide. It's the old P times 1 plus the percentage change as a decimal. Now, what's 9% as a decimal? Take a moment to think, everybody. 9 divided by 100 is equal to 0.09. So we're going to do this as $10 times 1 plus 0.09. Now, 1 plus 0.09 is a very easy thing to add up because there's nothing to the left of that decimal place. That's just 1.09. And so $10.00 times 1.09 is equal to $10.90. Now, again, you'd be doing this with your pencil on your paper. Please notice I am always writing dollars and cents for price. You cannot write it any other way. Class P equals to 10.9 means doodly squat in this class, because if this was Europe, do you mean 10 euros and 90 euro cents? Or is this Mexico? 10 peso y 90 centavos. Or is this, howdy, it's 10 Canadian dollars and 90 Canadian cents, eh? The problem is, without the currency symbol, you don't know what the heck you're talking about. We're in America, dang it. We're in the United States, and so we're going to be using dollars and cents unless it's stated otherwise. So notice here, you don't drop your decimals, 2 decimals for prices and revenues and whatnot. And we always have that dollar sign on the left. This is not Quebec. Merde. Okay. Now, since price is going up by 9%, quantity sold will have to drop by 5%. Again, remember, numerator is percent change quantity demanded. So that 5 is a 5%. This is not slope. That's a different formula entirely. Don't even think about slope right now. So Q will drop by 5%. So that means the new quantity is going to equal to 100 units. And don't drop the units here, folks. That is how we measure quantity. Let me do parenthesis on all of this stuff here, because I can hear Professor Hodge saying, hey, man, what you doing? You got to make sure that they understand what is what. Okay, fine, Abe. And then it's going to be 1, since we're decreasing, what goes here? Minus, and then 5%, 5 divided by 100 is 0.05. Now, 1 minus 0.05, 1.00 minus 0.05 is going to equal to, well, that's going to become a 0 to the left-hand side. That's equal to 0.95. Okay, so that is going to equal to, no dollar sign, bad professor, 95 units. Okay. Now, of course, I hear a lot of students out there saying, yeah, man, he's setting less quantity. How do you know he's got more revenue? Well, we'll know if he has more revenue or not, or she, if this is a business owner, could be either gender for that matter. Okay, the new total revenue is going to equal to the new price, $10.90. Times 95 units. Prices are implicitly per unit. Revenue is measured in dollars and cents. So let's run that through that calculator. This is what your calculator would show. 10.90 times 95 equals, is that number bigger than 1,000? Yes, it is. That is $1,035.50, which is greater than $1,000.00. And so we know we did the right thing. I've always got somebody that's going to want to play devil's advocate, say, yeah, but what if we had lowered price by 9% to $9.10? I'm not writing it there because that's wrong. You don't want to do the wrong thing. I want to focus on what's the right thing to do. But the thing is, for those of you who are devil's advocates or agitators, as I sometimes like to call you, if you had lowered the price to $9.10, the business would sell 105 units, but their total revenue would be $965.50, which is less than $1,000. This business wants to get more money, more money, more money. Why do you want to make them earn less money? Come on. Okay, so that's the first one. Let's talk about the second one here. E sub D is equal to negative 11/4. Okay, now here, let's take a look here. Let's remind ourselves of something. Okay, since E sub D is between negative infinity and -1, demand is price elastic. What we also learned here is if the demand is price elastic, the firm's total revenue will increase when they lower the price. Okay, so let's go back to our formula here. And again, I do not know why this thing is being so stubborn, let's just say here. It just does not want to be located in that spot. And Control X. I'll try to get it sort of force fit it over there if I can get it to work. And it doesn't want to work for some reason. Okay. Well, here's the deal. The percent change quantity demand is up top. The percent change price is in the bottom. And we have to change price first. So that's a 4% change in price. And so since demand is price elastic, we recommend lowering price by 4%. Okay, so the new price is going to equal to the old price, which is $10.00. And let's put that in parentheses here. Okay. And then we have to get the factor. The factor is going to be 1 minus 4% as a decimal is 0.04. All righty. Of course, having a calculator is the best way to go about this. This is like 100 divided by 4 is 96. So 1 minus 0.04 is equal to 0.96. And I'm saying this faster than I can type it. Okay. So $10.00 times 0.96 is $9.60. Don't drop those decimals. So our new price is now 4% lower than the old price. Now, as a result of the price dropping 4%, the quantity that is sold will increase by, what's the numerator say? It says 11. So Q will rise by, not 7, but 11%. I guess I'm thinking about 7-Eleven and a Slurpee. I don't know. And so the new quantity is going to be equal to the old quantity of 100 units. And then we're going to multiply that by 1 plus 0.11. 11 divided by 100 is 0.11. Well, you add those together, you get 1.11. And that's a very easy multiplication. That's going to be 111 units. Now, gee, I'm hoping you all realize I chose $10.00 and 100 units because these are very easy numbers to make percentage adjustments to. It doesn't require a lot of heavy-duty math, and it's less likely to have mistakes with the calculators. I could choose whatever numbers I wanted to, but then you'd have to deal with rounding and whatnot. And I'm trying to make the point. I'm not trying to make this too difficult for anybody here. So if this is the right thing to do, if lowering the price 4% will boost the revenue, the new total revenue will be greater than $1,000. And so let's take our new price times quantity is total revenue. That is the formula we learned earlier, $9.60 times 111 units. And again, I am not trying to reinvent the wheel here. I've got my calculator here for a reason. Let's clear that. 9.60 new price times 111 units. And you notice your calculator doesn't have dollars and cents. That's $1,065.60. Your calculator basically will only show the number of decimals that are considered necessary. But we are dealing with money. When we deal with the US dollar, it is legally required on all bill of sales and on all official price tags that be stated to the nearest penny, even when it's a ridiculously large amount of something. So the new total revenue here is $1,065.60, which is greater than $1,000.00. And so we know we did the right thing. All right. And so a couple of people are going to ask me, it's like, gee, professor here, okay, what if we had done the opposite? What if we had raised price 4% to $10.40? Well, $10.40 is going to make quantity sold drop by 11% to 89 units, and 89 times 10.4, and I'm not going to write this down because I don't want y'all doing this here, is equal to $925.60, which is less than $1,000. Again, we do not want, I repeat, we do not want, okay, to cause the business to have less revenue coming in. We want more. And so what I'm doing here is how you would work problem number 4 on your Unit 1 handwritten homework. But again, of course, you would handwrite this. I'm typing this for ease of reading, okay? But this is what you have to do. Make a clear recommendation about how to change the price and by what percentage. You have to calculate the new price. You have to make a statement of how quantity will change, calculate the new quantity sold, and of course, calculate the new total revenue and verify that it's bigger than the original. And we've done this both times here. So for those who basically were a little skeptical here, I want you to notice here that some businesses, they tend to face most of the time price elastic demand. They're going to tend to have sales periodically or specials to try to help boost sales and boost revenue. Businesses that sell the products that have price inelastic demand most of the time are probably selling necessities like water, staple goods, and especially electricity and gasoline. And so they can raise price by a pretty big margin, but people won't cut back their consumption as much as the price may increase, at least within a certain latitude. Now, the thing is, I've made a big old deal about the fact that price elasticity of demand is not slope. Okay, but the thing is, I need to also mention that it is not constant. Price elasticity of demand actually varies along a linear demand curve. Slope is always constant on a straight line, but E sub D varies. And the higher price range up here, big dollar value changes in price are small percentage changes. At the same time, since quantities are small unit changes are big percentage changes. So demand tends to be price elastic in the upper left-hand corner of the demand curve. However, as you move diagonally down to the right and price drops, it becomes progressively less price elastic until it hits a point of unit elasticity. That is not the midpoint, by the way. So the thing is here, once we pass this point of unit elasticity, demand becomes price inelastic. So if you currently face price elastic demand and keep lowering price, you can reach a point where you're not going to gain any more revenue, and then you'll start to lose revenue if you keep lowering price. Now, towards the bottom right-hand end, where it intersects the quantity axis, demand tends to be price inelastic. The reason why is because small dollar changes, 50 cents is 33% of about 50, are big percentage changes. And big unit changes, 100 units is 0.1% of 100,000 units, tend to be small percentage changes. So demand tends to be price inelastic towards the bottom. And so if a firm is facing price inelastic demand, they have some latitude to raise price and boost revenue until they hit that point of unit elasticity. And then once they cross it, they keep raising price, they start to lose total revenue again. Now, the thing is, there's some demand curves out there. The vertical demand curve is a weird case. We'll talk about that in a minute. Horizontal demand curve is actually somewhat common. But these types of demand curves will not have a point of elasticity because the vertical demand curve is an undefined slope. Quantity is constant, but price can change infinitely. And on the other hand, the horizontal demand curve has a slope of 0. You have infinite change in quantity, but a stable price. And so those are exceptions. Now, what's kind of interesting about it is that some businesses are in certain market structures where they face price elastic demand more often than price inelastic. And there's other businesses that are in certain market structures where they tend to face price inelastic demand more often than price elastic. In other words, the price elastic region can be larger relative to price inelastic or vice versa. And this actually is going to show up in the slant of the demand curve, like the elasticity is weighing down one side versus another, and the point of unit elasticity is like the fulcrum on a lever. So here is where there is a loose relationship with slope. Demand curves that are flatter have larger regions where demand is price elastic. So if you look at this demand curve over here, if you look at the vertical variation of the demand curve, it has a very narrow vertical or price variation. But look at the horizontal variation, it has a much larger quantity variation, and that's what price elastic means. Now, a special note, if I were to make a horizontal line down here and find the angle, that would be between 0 and 45 degrees. In other words, less than 45 degrees, and the slope would be like -2/3 or -1/2. We describe this kind of demand as being relatively price elastic, and there's two market structures that would fall under this description. Monopolistic competition. Fancy restaurants, certain luxury products tend to fall under monopolistic competition. They tend to have relatively price elastic demand, and a competitive oligopoly like cell phone services would also fall under there. A competitive oligopoly has a few large firms that dominate the market, but the firms are actually actively, aggressively competing against each other, and that makes demand more price elastic. We're going to learn more about these market structures down here a little later. Right now, I just want you to know that when you see a demand curve like this, it's either going to be monopolistic competition like a fancy restaurant or electronics store, or a competitive oligopoly like cell phone service. Now, When you have a very steep demand curve, and if I was to form an angle at the bottom with a horizontal line, it's between 45 and 90 degrees. The slope is like -5. It's between -infinity and -1. You tend to have larger regions that are price inelastic. If you look at the vertical variation, the dollar variation in price is much bigger than the unit variation in quantity. That's price inelastic demand in a nutshell. We describe this kind of demand curve as being relatively price inelastic. I use the relative terms because even this demand curve has a price inelastic region, but it's smaller than price elastic would be. Even this demand curve has a price elastic region, but it's smaller than the price inelastic. A monopoly, a market with a single seller, like say the local waterworks or the local natural gas company, are the main producer of electricity for the Houston area. I didn't say seller, I said producer. We have a two-layered market here, would be a monopoly, either regulated or pure. Now, notice the other term is a collusive oligopoly. A collusive oligopoly is a market with a few big sellers that dominate the market, but when they collude, they're working together to basically price gouge or screw over the consumer. OPEC, which is a cartel, is a collusive oligopoly. And there have been evidence in the past that the airline industry was a collusive oligopoly. They were actually prosecuted for that in court, in fact. And the tobacco industry as well was prosecuted in court for being a collusive oligopoly. So the thing is, please remember the demand curve is a steep negative slope, greater than 45-degree angle there. It's relatively price inelastic demand. That's a monopoly, either pure or regulated or a collusive oligopoly. Now, have y'all ever noticed those commercials for like certain sports beverages, especially Red Bull and stuff like that, Monster and so forth, Tantrum? They like to say the word extreme, but they don't just say it's an extreme experience. They say extreme. Well, here's the extreme cases of ECON. And now I'm sounding like the D-bags from Harold and Kumar who are driving around that yellow Xterra, screaming the word extreme at the top of my lungs. A horizontal demand curve, perfectly flat, has an E sub D coefficient of exactly negative infinity and a slope of 0. We describe that as being perfectly price elastic. A market structure called perfect competition, which has an extremely large number of extremely small sellers, many hundreds of thousands. Each seller sells less than 1% of the market output. Everybody sells the same thing. Your agricultural businesses like corn farms and wheat farms and dairy farms fit the description of what we call perfect competition. We're going to study perfect competition in more detail in Unit 2. Now, on the flip side, if you have a vertical demand curve, the E sub D coefficient is 0, no variation in quantity, infinite variation in price. That is called perfectly price inelastic demand. Perfectly price inelastic demand, excuse me a second, didn't mean to go there, would be an unusual product that has no close substitutes of consumption. One example of this product would be table salt. Class, table salt has a very long shelf life and people tend to use it very slowly. I said people, not restaurants. Let's be careful. We understand each other here. I buy a pound of salt like every few years. Okay, the price could be 4 or 5 times bigger than it was before, meaning a 300 to 400% increase in price, or it could be half of what it was, a 50% decrease in price, but I still buy 1 pound of salt every few years. Some other examples include highly addictive narcotics, some of the life-saving pharmaceuticals used for cancer and certain types of bacterial infections. And you could also include, prior to the invention of RNA insulin that was extracted from cattle and pigs was perfectly price inelastic. And the price was highly volatile because of the fact that diabetics who need insulin to live will die without it, and they'll be living a horrible experience before they die. And so you got to have that insulin shot on the regular basis if you're a type 1 diabetic. And so the demand for that kind of insulin prior to the invention of the RNA insulin was perfectly price inelastic. So once you understand, E sub D isn't slope, but it does have kind of a loose relationship. It also, I want you to understand here, perfectly price elastic demand, the business has no price control. This is not a market demand curve. This is an individual business's demand curve. And P star is market equilibrium that's determined by supply and demand, and it only changes when supply and demand shift. Perfectly price inelastic demand, the drug pusher can start raising prices once the junkie gets addicted, and they can raise it 2- and 3-fold. Well, that means the seller has absolute control over price. In the case of relatively price inelastic, the seller has a bit more control over increasing price than you would like them to. In the case of perfectly price elastic, the seller needs to make sure they keep the customers coming in by periodically lowering prices. A restaurateur friend of mine named Jonathan Levine told me, I have daily specials because people who come in will look at the specials, but they may buy some other stuff that's not marked down. And so I use the specials to get people in to spend more money on the other items, and that's how I make my money. And so having sales on some items, but not others, like ladies, for example, a lot of department stores will have a sale on shoes, but not on purses and hats and other types of accessories. They'll get people in to buy the shoes, but unless they're thinking very carefully, they'll end up buying some other items that aren't marked down. Okay. And again, that's a strategy. Department stores like Dillard's tend to have relatively price elastic demand. And so this is some interesting stuff here. So let me get out of the sharing mode here. I'm going to go back over here to what we've been dealing with here. We're going to stop sharing. I'm going to go back to the camera now. Okay. Folks, again, I very much appreciate the time y'all have put in here as far as trying to cover the material during this hurricane. Again, Lone Star College is starting back tomorrow. HCC starts back on September the 11th. I hope these videos are helpful and are going to kind of reinforce things. I know they're not quite a substitute in consumption for actually being in class, but hopefully they'll fill in a necessary gap. Have a good day, everybody. Happy Labor Day, and I look forward to seeing all the Lone Star students tomorrow. Have a good day.